Hello, my name is Francis Chung, and welcome to my talk on building testable phone applications. If you have any questions, make sure to tweet to #CH9Live. Let's just jump right in. Today we'll be talking about fast app switching and how it pertains to MVVM. Now, fast app switching is pretty well documented. If you go to an MSDN, it talks about how to deal with fast app switching and how to incorporate fast app switching logic into your Windows Phone applications. However, there are not many examples on how to do it using MVVM. If you're a big fan of the MVVM patterns, especially when it comes to enhanced testability, we'll show you how to incorporate fast app switching into MVVM. Next, we'll talk about unit testing against Windows Phone 7.1 SDK applications. Now, we're not talking about unit testing the SDK, we're talking about unit testing your source code, your business logic that is in a Windows Phone application. So if you're leveraging the geolocation watcher or the camera capture task, we'll show you how to unit test your business logic that happens to leverage those APIs. Next, we'll talk about how to run unit tests, how we made a choice on the test runner itself, and how those choices impacted our ability to automate the unit tests run on MS Build. Next, we'll talk about marketplace certification. Now, if this is the first time, if you've never actually submitted an application to the marketplace certification team, you'll definitely make sure to pay attention to this section. I hopefully will save you a whole lot of time, potentially even months of time. And finally, we'll talk about the background agent. So let's first start talking about the Windows Phone application lifecycle. Here's a diagram pulled straight off of MSDN. You can see here the application level events are in red and the page level events in blue. You can see here when an application is launched, you've got the application launching event, you've got the page navigated to event, and then you're running. Now, you've got a running app, and then all of a sudden you hit the home button. You basically have deactivated your application. At this point, we'll go over here to the page navigated from and the application deactivated events. This is now your opportunity to stash away any page level or application level state that you may have acquired. Now, at this point, you've really left your application, or you're about to leave your application, you've stashed away your state. You don't know whether your application will go back in from a dormant state or from a tombstone state. You don't know. That often depends on memory pressure. So this is really your opportunity to go and stash away any state. Having your state stashed away, now you enter your dormant state and potentially your tombstone state. Now, prior to Mango, your applications would typically go into dormant state maybe for just a bit. You immediately get into tombstone, and then if you were to return to your application, it would have to be rehydrated through the application activated event and page navigated to event. Now, that was pretty standard. Since most applications were returned to from a tombstone state, basically everybody wrote logic to deal with that situation. Now, in the Windows Phone 7.5 OS, or the 7.5 OS, also known as Mango, you have a lot of cases, I'd say maybe the majority of cases, are that your application goes into a dormant state, you hit the back button, and you return from that dormant state right back into your application. Now, when your application is in a dormant state, the application pages and all the objects within your application, they're still in memory. So when you return from your dormant state, you don't have to go and rehydrate. That rehydration logic takes some time. So if you were to come back from dormancy, you would just go ahead and avoid all that rehydration logic and get back into a running state. However, if you were to go into your tombstone state, all of your objects in memory would be gone. You'd have to rehydrate them from the state that you stashed away over here. So you get into tombstone, you do your rehydration, and you're back to running. So the trick here is to determine in your business logic, or hopefully in some framework logic, when you were coming back from tombstoning or when you were coming back from dormancy. If you can avoid the tombstoning logic, you have now achieved fast app switching. Let me show you how that's actually implemented. So let's go to our tailspin solution. Our tailspin solution you can find in our guidance. If you go and download our guidance, I'll show you the URL later. We'll take a look at how we're implementing. Actually, no, let's go to the MVVM sample, which is also in our guidance. Our MVVM sample has two different projects. It has a code behind version of a petrol tracker. It also has an MVVM version. I'll get to the MVVM in a bit. Let's take a look at the first page in the petrol tracker. This page has an onNavigated_to method, which really is called based upon the navigated to event. So this is saying that this page has been navigated to. We first check if this is a new instance of the page. If this is a new instance, either because you came back from tombstoning or you're hitting the page for the first time, we now have to do some setup logic for the page. Now down here we check the start mode. Start mode could either be activated or launched. If you're starting from the first time, it would be launched. But if you're coming back from tombstoning, it would be activated. We also check one more thing. We check the state bag. If you've stashed something into the state bag for recovery from tombstoning, the state bag would have some contents. However, if you've navigated from, let's say, page A to page B, once you've landed on page B, there's not going to be anything in that state bag. The page handles all that logic for you, so you don't have to worry about it. So here, we're checking that. We're checking that it's activated and there's nothing in the state. If that's the case, then we're coming back from tombstoning. Sorry, let me take that back. Let me rephrase that. If we're activated and there is something in the state bag, then we are coming back from tombstoning. In which case, we run the rehydration logic here. If we don't, we can just go right back into the application. Deonce is false, so I don't have to go into this logic again. And then we have achieved fast app switching. Again, this is the code behind example. Let's take a look at the same project, but in a MVVM style. Here we've got the same page. The view model, the code behind of the view model version also has a onNavigated_to event. In this case, we follow a similar process and we check the start mode. We make sure that it's activated, and that's stored in the is being activated property or variable here. We also take the state of the page and we pass that both these values into the navigated_to method of the view model. So in this case, you've got the view really delegating responsibility to the view model to do a lot of the work. So let's take a look at the add fill-up view model. So this view model now checks if it is a new instance. If it's not a new instance, then perhaps we're coming back from dormancy. So this is a new instance. If it is a new instance and it is being activated as opposed to being launched for the first time, and there is content in the state bag, again, that would be scrubbed clean if you're navigating from page to page. If those three cases were to be true, then we are indeed coming back from tombstoning. If that is the case, then we run the page hydration logic, or in this case, the view model rehydration logic, and then we flip that bit. Okay? Again, we want to avoid running this hydration logic if we are coming back from dormancy. That's the whole crux of this. Now, you may ask the question, well, can I just avoid all this logic altogether? Because chances are, if you go back to the slide deck, chances are most applications will go into dormancy and back if there's no memory pressure. well, that's a big if. And number one, that's a big if. Number two, if you don't add logic to deal with tombstoning, it won't pass certification. So it's important to do. All right. Our last example will be showing how to deal with dormancy and tombstoning using more of a holistic approach. So here, this second approach uses a view model, but it captured or was passed state from the view. Let's take a look at another example. Here in the Tailspin solution, if I go down into the phone client project and take a look at a view, let's take a look at the app settings view. And here's the code behind. As you would guess, there's not much logic in our code behind. There is an associated view model associated with it, and that's referenced in the XAML itself. You can see here that there is a data context, and it's bound to the app settings view model property of the view model locator. So that's how we're tying together the view model with the view itself. So let's take a look at that. So here's our view model. First thing you'll notice is that the view model extends a base view model. Let's take a look at that. The base view model listens to a couple events. It listens to the navigated event and the navigating event. These are similar to the navigated to and navigated from events or methods that you see on the page, but they're a little bit different. The navigated event means that we've navigated to a page. Not necessarily the page you're interested in, but we've navigated to a page. Again, this is at the navigation service, so it's at an application level event. Same thing with the navigating. Navigating means that you are navigating from a page to another page. You don't know if either of these pages are pages that you care about, so we have to make that check. So let's take a look at this event handler for the navigated. So this is saying that I've landed on a page. So the first thing we check is, do I have to resume from tombstoning? Do I have to care about that? So let's see how we figure that out. What we're doing is we're delegating to the navigation service the responsibility of figuring out if I need to recover from tombstoning. And I pass it a specific page URI. The reason for this is because, again, this is an application level service. It doesn't really know where I am. So I'm saying I am I am a specific page. Now, imagine that you've got 3 pages in your application, and maybe 2 of them, page A and page B, were involved in tombstoning, but page C was not. It was never even hit. Or maybe you hit page C and you came back. It wasn't even in memory while you were tombstoning. So it shouldn't participate in the recovery of tombstoning process. So this service here handles all that business logic for us. Okay? And what we also see here is that if this page, if we are recovering from tombstoning, and if the page that we've navigated to is the page I care about, then we call on page resume from tombstoning. In this case, it's an abstract method, and so we'll see the implementation of that in an actual or concrete instance of the view model. In this case, we're looking at this one, so we'll take a look at its on page resume from tombstoning. So this is all of the, again, as I mentioned before, the rehydration logic that we need to run in order for this view model to recover from tombstoning. And as a developer, all I have to remember is to extend the base view model and implement this method and put all of my rehydration logic right here. I don't have to do any of the checks. All the checks and management will happen in the base view model. Okay, so you can see that's just all the rehydration logic. Another thing that we do in the base view model, if you go back up to the events that we listen to is we listen to the navigating event. So let's take a look at the event handler here. The navigating event needs to figure out whether the navigation occurred because of a normal page-to-page navigation. If I'm on page A and I'm navigating to page B, we'll call that an intentional navigation. However, if I'm on page A and I hit the home button, I'm actually deactivating. The navigation event will fire, but we'll call that an unintentional navigation. So in that case, either way, we pass the value of the navigation. In this case, it's described right here, the two styles of navigation. And we pass that Boolean value into the on-page deactivation, which we can see in the implementation of here. So here on my app settings view model, so my concrete implementation of a view model, we have code that says, well, if I am navigating from page to page, if my navigation is intentional, just go ahead and get rid of me. You don't need me to hang around. I'm one of these pages that it's very transient. You can come and you can go, and when you leave me, go ahead and get rid of me. So that's specific to this view model. So I can now know you can get rid of me and you can return. However, if you are if you are being deactivated, then go and do all this logic that will capture my page state, my view model state, and put it away into local storage, isolated storage. In this case, we're using the phone application service facade for that local storage. Right? And again, feel free to tweet any questions you have to #CH9Live. All right, so that gives you the 3 cases. We have a demonstration of how to recover from tombstoning and dormancy through a code behind, also through an MVVM, but it's not pure MVVM in that it still has a relationship with the code behind, and the code behind is passing it some values. And then we're showing how we're actually handling all the management through an MVVM or view model based class. Any questions? Feel free to ping me. Otherwise, let's go ahead and talk about unit testing against the Windows Phone 7.1 SDK. Now, typically, your app will want to use certain APIs, for example, the camera capture task that we have here. So you've got your app calling the camera capture task. That's what you typically see in a phone application. But what we also want to do is we want to unit test the code in your app. So what we want to do is have your app call the camera capture task at runtime, but when you're running your unit test, you want it to potentially run a different set of code, for example, a mock camera capture task, so we don't have to actually deal with the camera, right? So in order to implement that, what we're going to do is we're going to introduce a point of substitution. Here we're introducing the concept of an interface, an iCamera capture task. The iCamera capture task will basically provide all the functionality that you have in your camera capture task, but it'll allow you to substitute what we have over here for what we have over here at unit test time. So the issue here is that the camera capture task provided in the Windows Phone API, well, it doesn't provide an interface. It doesn't actually implement iCamera capture task. That's something that we just dreamed up. So what we've done in our guidance is provided that for you. We've provided an iCamera capture task. We've also provided the camera capture task adapter. And the adapter is nothing more than a pass-through. It's just a piece of code that passes all the properties or the parameters that you call into the adapter straight through into the actual Windows Phone API. Passes them through and raises events. When it receives events from the API, it just passes those events back. So it's really just a pass-through. But the trick here is that it implements the iCamera capture task. Also, the mock camera capture task implements that same interface, so that at test time you can get this one versus that one. So when the app runs, since it depends on the iCamera capture task, the application will resolve a camera capture task adapter, which really just wraps the camera capture task. At unit test time, when it runs, it depends on the same thing, and the resolution will give it a mock camera capture task. Now, when I talk about dependencies and resolution, I'm really talking about using a container. So if you really want to see how we've actually implemented a container, go ahead and download our code and take a look at how we've done that. So let's take a look at a unit test against the Windows Phone SDK. We're back in the Tailspin solution. Crack open the test project. Here we see the Tailspin phone client tests. So this is a test against the phone client assembly. If you go down to the picture question view model fixture, we see a test. We'll take a look at the first test here. This test just validates that my view model communicates to the camera capture task, in this case the adapter, and once it gets data back from the camera capture task adapter, which would be in the form of an event, but it would have the payload of a picture, that it takes that picture and sets it into a property that is iNotify property change. So the view knows about that property and then can show an updated version of that property into the view. Now, this is a very simple test, and my view model doesn't do very much except for take that value and present it. But your business logic could be doing a lot more. You could take that image, you can manipulate it, you could be doing a lot more, and that's what you would really be testing. But in this case, we're just testing that it takes the image from the camera capture task adapter and presents it into my picture property. So let's take a look at that. First, we have a mock camera capture task. Let's take a look at that mock for a second. The mock implements the interface as we mentioned before, but we've also got a lot of other things in this mock. Let's take a look at the project that this mock is in. In this case, it's in the Tailspin phone test support project with other things, for example, a file log provider that I'll talk about more later, and other mocks. Now, this is a good representative mock because it does a couple things that I want to point out. One thing is that it really is similar to the API of the actual thing that we're replacing, which is the camera capture task. In that the camera capture task, let me take a look at that API or that interface. It really just allows you to call show, and when show is done, at some later time, the completed event is fired. And it's fired with these event args. So that's basically it. Now, the mock version of that allows us to do a little bit more. We can set the event args that we want the completed event to fire. So that's a property that we can set here. We also have a show method. Now, the show method checks to make sure that the task event args is populated. If there's nothing, then we'll go in through an exception. But it also, here, I'll get to this line 20 in a second, but it goes and checks that maybe that something is listening to the completed event. If something is completed, if something is listening to the completed event, we'll go ahead and fire it, passing in the event args. Now let's get back to line 20. What we're doing here is we're allowing an action callback. We've got a property here that you can set to say that if show is called, go ahead and do this extra piece of logic. You can set that in your unit test so that you can have the mock do really anything you want. If you wanted to do some custom logic like throw an exception, throw a custom exception, maybe the camera is broken, or you want to test if there's not enough space or whatever condition, you can provide that functionality in the form of an action. You can set it into this mock, and when the show is called, it'll fire. That's how that works. So generally, we've provided that functionality in most of our mocks to provide the ability to give it your own custom behavior. Okay, so let's get back to the test. Again, this test creates the mock camera capture task, and next 10 lines, lines 20 through 30, really just set up the mock. Just tells the mock what to return. For example, over here, it's going to return this JPEG. And we know a lot about this JPEG. We know it's static. We know about it. So we can validate that the view model at least had it from a starting point. Now on line 34, we actually construct our view model. Passing in, as you can see here, the mock camera capture task, we can pass it in because it expects the interface. So after we construct our view model, we verify that the current picture is null, and then we start listening to the property changed event of the view model. The view model is iNotify property change, so we'll go ahead and listen to that event. And then we only care about the picture property changed. So if it's not the picture, we cast it away. Now if it is a picture property that's changed, we go ahead and interrogate that picture. So lines 41 through 42 do that interrogation. And then we mark the test complete. And the next line here is really what kicks off the whole process. We're executing the camera capture command, which calls show on the interface, which calls show on the mock, and the mock just returns that hard-coded image. And then the rest is history. So again, this doesn't do very much. This just validates that it moves data from here to there. If your logic does more with the picture, you can insert that logic right here. Right? Any questions? Let me know. All right. Let's move on to running of the unit tests. Now, when we looked at writing unit tests for Windows Phone, we took a look at various options for unit test frameworks. The one biggest option was the Silverlight unit test framework provided by Jeff Wilcox. The main reason why that was really valuable was that it ran the unit tests on the device or on the emulator. So that was very important because that really mimics the behavior that eventually will be the end behavior. You can, however, use Visual Studio and use the MS test runner within Visual Studio. You can build a test assembly and compile it against the full .NET framework. That will run, but that will not necessarily give you the exact same behavior as on the Windows Phone or on the emulator itself. So if you're okay with a slight varying in behavior, then it may be easier to write your test against the MS test within Visual Studio. But we decided to make it a little more sure that the behavior we're getting in our tests are the same behavior that people will be getting on their phones. So we wanted to run our tests against the phone. Now, after we've made that decision to run our tests against the phone, we realized that, well, we've got all these great unit tests running against the real hardware or against the emulator, but now how do we get the data off of the emulator or the hardware? Because what we really want to do is we want to fire an MS build command on my server and run all the unit tests. Now, how do I do that if the unit tests are run on a phone or on an emulator? Well, first thing we did to do that was to create a file-based log provider. Log provider is an extension or is a class in the Silverlight unit test framework. And the file-based log provider captures the Silverlight unit tests through the Silverlight unit test runner, captures that content, and writes it to a file in local storage, in isolated storage. We then wrote a custom MS build task that deploys our test projects to the emulator or to real hardware. It executes it, and then it it waits a certain specific amount of time, and then it captures the results. Captures the results from the phone and brings it back onto the server. Let's take a look at that. So here's our file log provider. You can see here that we've got a hard-coded path to a file. This is a hard-coded path to a file on the device. So this log provider will always write to the same place, always write to the same file. And this is, it just extends the log provider, and it overrides several methods to really process the reminder or process the message. We'll go ahead and make sure that the test folder exists. If it's not, we'll create it, and then we'll go ahead and write the contents of the message to the file or append it. Okay. Again, we're always writing to the same place. So that's all that the file log provider does. Next, we have a build project that goes and builds all the solutions and does the rest of the work. Let's take a look at this one. So here's an item group that identifies all the solutions that need to be built. This is the code under test as well as the test projects themselves. It builds all of them. Here's the call to MS build. And then here under our test target, we have our calls to our custom MS build task, as we've referenced up here. Here's our DLL. And so we call our custom MS build task, passing in a specified number of seconds to wait. Now this is because I don't have a great way of finding when the tests are done. If you can figure this out, feel free to update this. But right now, I just have it hard-coded to a specific number of seconds. So this task will wait a specific number of seconds and then expect the content to be harvested. Next, we'll also pass in to the target the path to the ZAP file, so it can know where to copy the file from. And we also pass it the product GUID, further identifying what project I need to execute. Okay, so let's take a look at the implementation of that task. Here's the task itself. You can see here there's some properties that you can set. And in the execute here, we do some logging. We then connect to the emulator. We then make sure that the application has been, well, we check if the application has been installed. If it is installed, we go ahead and uninstall it, and then we reinstall it, passing in the path to the ZAP file. So we really want to make sure that we've got the latest version of the code running in our test. After we've installed the application, we launch it. Then we wait. Again, this would be the place where we would do the check for when it's done, but until then, we have this hard-coded number of seconds. And then after we finish the waiting, we call get isolated store. Isolated store, get isolated store is actually from the Smart Device Connectivity API. So this allows us to transfer data that's on the device off into our server. So you can see here, we're calling the receive file method, saying, go and get this file, and remember this is the same file that the file-based log provider writes to. It's going to harvest that content and put it onto a file with this name on the server. So now we've got the file on the server. We can then read the contents of the file and then interrogate it. What we're doing here is that we're interrogating the file that we received from the phone for a failing test. So here we're looking for text exception. Fortunately, I didn't find anything else in the log that would really specify a failing test, so this is what I've got. And if we do find a failing test, I go ahead and log it and return false. Otherwise, all the tests are good. That's basically it. Okay. Now, let's talk about marketplace certification. This is specifically important if you're about to submit your application for the very first time. We submitted the sample application, the Tailspin application, to the certification team just to make sure that we understood the process, and we learned a lot. So here's a link to the full certification requirements here. Now, these are a lot of certification requirements. A lot of them are automatable. As a matter of fact, if you look here in Visual Studio, there's the Marketplace Test Kit that has automated a lot of these tests. So you don't have to go in one by one, test them by hand. A lot of them are automated for you. I'll show you how that gets run in a little bit. But more importantly, because this is the harder part, are the manual verification steps. When you submit your application to the Marketplace certification team, they run their automated tests, but they also run a lot of manual tests, because there are things that are a lot harder to test. For example, let's say that you wrote an application that uses the geolocation watcher. Very typical. That's a very cool feature that people use. Now, if you use that API, you're basically capturing relatively sensitive information. You're capturing where the user is. You're capturing their lat long. What you do with that information is very important. And it's very important to tell the user what your privacy policy is. Now, if you don't, you will fail one of the manual verification steps. There's a specific application policy about your privacy policy. You need to make sure you present your privacy policy to the user in the form of a tappable link or in the app itself. So one thing we did incorrectly was we didn't include a privacy policy, so it failed certification. Then we included a link to the privacy policy, but it wasn't a tappable link. It was just the URL in text. So that failed again. Now, when you submit your application to the Marketplace certification team, you might get a response back in 2 weeks. And you might get 2 errors back. Does that mean you only have 2 errors in your application? Unfortunately not. So you need to make sure that you go through all these certification requirements beforehand, because otherwise you're going to wait 2 weeks for every iteration. And it may take you several iterations to get through this process. So get through all of it as soon as possible. So what we eventually ended up doing was including the privacy policy right into the application so that you could see it in the About screen. So it was all right there. So if you get all of them passed through the first time, or make sure your test team really hammers on all the requirements. A lot of them are testable through automated verification, but a lot of them are not. So make sure that they cover all of those requirements. So let me show you how to run the automated tests. Let's go back into the Tailspin and make sure we're looking at the Tailspin phone client here. And if you've got a phone project selected, you can go over here to the project menu and go down to Open Marketplace Test Kit. This is available to, again, phone projects. And under automated tests, you can go and run these tests. We're all green here, but this doesn't mean that this will pass certification again. There's a lot of manual tests they will run, and a lot of them are mentioned here and under manual tests. But to be sure, make sure to go back to this URL under here, as well as the application policies. Make sure those are all good. All the I's are dotted, T's are crossed. That will save you a lot of time. Okay? Let's see. Okay. Background agent. Now, the background agent is a feature in the 7.1 SDK. Now, before we had the background agent, the fictitious Tailspin company wrote this application. But since we didn't have the background agent, we were able to put all the functionality in one project. So we only had one project, tailspin.phoneClient. After Tailspin decided to provide background agent support, they realized that, hey, the background agent needs to live in its separate assembly, its own project. So we have to split that out. So now you got the phone client project, and now we got the phone agent project. Well, you have a lot of code that they share. For example, phone services, services that talk to services, web services, and so forth. We go ahead and put those into another project so they could be shared. We also put the adapters that I mentioned before, the adapters and the interfaces, into their own projects. And all of a sudden, we went from 1 project to 5. So we saw a little bit of an explosion there. But that's necessary because the phone agent is required to be in a separate assembly than the phone client. So let's take a look at how that's structured. So in the tailspin, what we see here is, let me go back to the phone client project here. If you crack open the WM app manifest file, you can see here that we have a background service agent, and it specifies the phone agent. So there's a relationship here between the phone client and phone agent. When the phone client gets loaded for the first time, it goes and loads the agent. The agent can then do a lot of other work. For example, what it does, let me go and crack that open. So here we've got the phone agent project. The scheduled agent here, let's go into the invoke. Okay. So what it does first is it checks to see what types of tasks there are out there. There may be periodic tasks or resource-intensive tasks. So it handles them differently. So a periodic task may be something that goes relatively quickly, like a quick call to the service to get a little bit of data back. So in this case, we're dealing with a fictitious company that deals with surveys. So let's say a call to get a survey back would be quick. So that would be a good example of a periodic task. An example of a resource-intensive task may be something that takes a lot longer. For example, sending a picture that we've captured on the device back out to the server, that may take a lot longer time. Or a voice recording or something like that that you could do on your phone that would take longer. We would need to make sure that would be run as a resource-intensive task. So that's what the scheduled agent does. Right. And another thing with the scheduled agent, or the background agents in general, that we found in our application is that with the advent of background agents, if you've got an application that runs in the foreground, in this case the phone client, and then a background agent, let's say we call it the phone agent, you potentially could have some contention issues. You could have both the foreground application and the background agent having a contention over the same resource. For example, if they both edit the same file. Let's say the foreground app completes a survey and it writes to a file. Well, the background agent could be writing to the same file. So you have contention issues potentially. So in order to get around those contention issues for us, we decided to make this simple and have the background agent not run at the same time as the foreground agent. So when the foreground agent gets loaded, it goes and disables the background agent. When the foreground application closes, it goes and enables the background agent. So if you're in the case where you want both running at the same time, you'll need to add logic to handle the locking, the proper locking, so that you don't run into these contention issues. One easy way to implement this is to use a real database. We just used a file just for simplicity, but if you use a database, that would provide all of your locking functionality. All right. So here are some additional resources. We have the Windows Phone Developer Guide by PNP. If you go to this URL, you'll see all the code that I've shown today. You will see the MVVM training, which included the Patrol Tracker, the code behind version, as well as the full, as well as the MVM version of the same application. You also get the Tailspin application, the Tailspin reference implementation actually. You'll also get some samples on further testing of the Windows Phone APIs, for example, against the sensors, against the other various pieces of the API. And here's also a link to the Silverlight unit test framework. All right, so I guess we have no questions. I was that clear, I guess. Either that or nobody's doing phone development, which is not the case. So if there are no questions, then thank you very much. I really enjoyed working on this project. I learned a lot about phone development, and hopefully this gives you some valuable feedback. Thanks.